Hey guys, welcome. Let's take care of this problem that we're. All right, so here we go. This is a contextual question, part Dukes, because we're doing it again. You just got to put a little bit of thought into it. This is from the 2007 exam. Notice that this one says ABBC. That's because AB and BC shared the same question. Remember that the BC exam is 60% AB, so some of the questions are shared. So this would have been one that was shared. So let's see what the axis says. It says gallons per hour, so we're dealing with some type of liquid here, and then hours. All right, let's see what number one says. I'm going to read it so I can get in the problem. I haven't read it fully, so let's see. The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0 to 7, where t is measured in hours. In this model, rates are given as follows. The rate at which water enters the tank, f of t equal, okay, so right here for that, so that's a rate in gallons per hour between 0 and 7. The rate at which water leaves the tank, so this one's out, so put the word out, and that one's g of t. Notice that's a piecewise function. Between 0 and 3, it's 250, and between 3 and 7, it's 2,000. So immediately I'm going to come up here, and I'm going to write g of t. And then this line, the horizontal line has to be g of t, because see, 250 and 2,000 doesn't have a variable in it. And so that means this one right here must be f of t. Are we still okay? All right, so let's see what are we going to do now. The graphs f and g, which intersect at, oh, wow, they're giving us that value. So this value right here is t equals 1.617, and t equals 5.076. So that must be, I wonder why they're giving that to us. We could have solved for it. What was that value? 5.076. T equals 5.0, I forgot, 076. All right, shown in the figure above. At time t equals 0, the amount of water in the tank is 5,000 gallons. So put that somewhere. I guess we can use the letter A for amount. A. Yes.
If at t equals 0, the amount of water in the tank is 5,000 gallons, shouldn't that be shown on the graph?
No, the graph is a rate. It is not how much water is in there. All right, let's see what letter A says. How many gallons of water enter the tank during the time interval 0 to 7? Round your answers to the nearest gallons. Okay, do I have to show any work, quote unquote? You just got to show it's called the setup. So what do I do? What do I write? Integral. Look at you guys being beef. 0 to 7 of what? F of t. Yep, make sure to put the differential. Put f of t in your calculator. We're probably going to need it again and again. So y equals 100, and I already forgot it. X squared, 100x squared. So 100x squared sine of what? Square root of x. So there it is, 100x squared sine squared of x. Make sure you don't have any copy errors. And I'm just going to go math number, oh, that's not math. Math number 9. 0 to what? 7 of my y1 alpha trace. y1. Do not use calculator language. So do not use y1 on your booklet or in any exam. 8263. Did it tell me to round? Round your answers to the nearest gallons. Okay. So if I'm running to the nearest gallons, I'm going to say 8,264. 8,264. Yeah, I'm going to put units. If there's units, put units, gallons. That was a rate, gallons per hour. DT's in hours. So gallons per hour times hours is gallons. Are we okay with that? Perfect. Nothing crazy so far. Everything seems okay. Continued. Let's see what it says. Between 0 and 7, or 4, where t is between 0 and 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for your answers. Okay. This was f of t. Remember that f of t was the amount in. It's a rate. And this was g of t. And g of t was the amount out. Are we still okay? All right. Just do it with logic. If there's more water coming in than water going out, is the amount of water increasing or decreasing? Increasing. If there's more water going out than the amount going in, is the amount of water increasing or decreasing? Decreasing. So I need to find what do they want again? Decreasing? I need to find where the water is going out at a faster rate than the water is going in. Does that make sense? You have the rate in and rate out. I am looking for where G of T, that's the out one, is larger than the F of T. Do you guys see that? Well, I can look. I'm going to highlight. I'm going to change my color to blue. So if you have colored pencil, this is a good one. Use your black ink and blue ink when you're taking this exam. I can see that G of T is bigger than F of T right here in blue. Do you guys see that? And I can see that G of T is bigger than F of T right here in blue again.
Oh, so then do we do like after and then it'll go from 0 to whatever that number is?
Yeah, that's probably why they told us our T values, because it would have been hard to do the piecewise functions in our calculator. So, and we already got these T values, right? They gave it to us. Yeah, and we're just going to say because G of T is bigger than F of T. So first I'm going to state the conditions and then give the where the values are met. So I'm going to say,
You didn't do any math? Like,
we don't have to do anything, just the logic. Just the logic. So that's why I put, let's use our logic. So here we go. I'm going to say amount of water in tank. I'm just using the stem of the sentence. Amount of water. I put H2O to let them know that I know chemistry. 2 hydrogens and an oxygen. That's a joke. LOL. Amount of water. I think you could be safe with that, by the way. Amount of water in the tank is decreasing when G of T is greater than F of T. This is how you say G of T is greater than F of T. I'm going to put semicolon, and I'm going to write this occurs on the, bless you, and there's 2 time intervals. On the time intervals, let's see, which is the first one? 0 to 1.6, was it 617? And from 3, and notice that I'm putting parentheses on everything here. 5.076. Close. That's full credit right there. The logic sounds, the math is mathing, we're good. What's up? That's fine. You can say the word union, but I would have used the word and, because those are the 2 intervals that it happens.
why did we use parentheses instead of brackets?
You can always use parentheses, and that will always, like, they will outlook it. But I can see there's like something funny happening right at the 3. It's just I let's see what the rubric says if they use brackets. But I think parentheses is always the safest bet. Hit me one more. Yeah, if it was position, velocity, acceleration, I would have, depending on how the questions were, maybe I would have you increase and decrease on an interval. But depending on, okay, yeah, I'm not, yeah, that's not. All right, what's the next question? LOL. Are we okay with that? Houston, we're okay? Okay. Let's see what the next question says. Between 0 and 7, at what time t is the amount of water in the tank the greatest? To the nearest gallon, compute the amount of water at this time. Justify your answer. Okay, I don't know. Let's just look at this graph and see what's up. So from 0 to 1.617, the amount of water is decreasing, right? And then between 1.617 all the way to that moment, I have more. Wait, is that decreasing or is that increasing? Oh, yeah, because I have between here and here. Okay, no, not between all the way over there. Between 1 point blah, 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 whatever that is, and 3, the amount of water is increasing because there's more water going in than out. Yes or no? And then, of course, this is why they probably asked letter B. This burnt orange, this is where it's decreasing again. And then back to this purple part, I am increasing. So I'm going to make a table, T, and then I'm going to say amount of water. I can't even spell amount. Yeah, we're going to try to figure that out. So my critical numbers are, let's see, what are my critical numbers? I guess one critical number is 1 point, but that's not going to be, okay, put it in here just so you can state that we know our critical numbers. Chop, what are you doing? I'm doing this, guys, where f of t minus g of t equals 0. Or where f of t, that's the same thing as saying where f of t equals g of t. So 1.617, and that's going to be an A, because that's a min, right? because I was water. It was decreasing, and then after I passed that moment, now I started increasing. So we're not gonna worry about that one. Bless you. At three, that's a max. So we're gonna have to figure that one out. And at yeah, and then what was the other one? 5 point what?
5.067.
Is that another min?
Oh wait, 76. Sorry.
5.076. That's another min, right? And then finally, what's my last? 7? Oh man. Let me make this smaller. So they couldn't fit it. Min NA. What was it? 5 point whatever? 5.076. Okay, do you guys know what I'm doing, guys? Yeah, what's up? Hit me. From right here. Right, here's where I changed. G of F of T was bigger than G of T, but then at a moment's notice, G of T is bigger than F of T. So I know that I have a local max. It could be an absolute max. It's either going to be at 3 or at 7. We're going to find out right now. What's up?
Does 5,000 have any part in figuring this
Yeah,
out?
that's the amount of water. That's what they want.
So
that's
we add
part of
that to the integral?
We're going to add that to, yeah, that's the initial.
Okay.
Help me again, Houston? I mean, sorry, because I was talking to Houston. Hit me again.
You did 3 because that's the, like, why is that?
I did 3 because I know that I have a local max there. Because that's where, okay, I guess I'll say this. F of T minus G of T. That's my net rate. Net rate. Right at 3, I switch from positive to negative. Or from increasing to decreasing. Well, positive to negative. That makes sense? Okay. Are you sure? For sure. Okay. Okay, right before 3. You see this purple here? All this purple? See how F of T is larger than G of T? So right now, F of T minus G of T between 1 point whatever and 3 is greater than 0. Right after 3, F of T minus G of T, right after 3, is negative. See? Because now G of T is bigger than F of T. Look, you do upper minus lower, and if G of T is bigger than F of T, I'm going to get a negative value. And if I do this F of T minus G of T, that's going to be a positive value. So right at 3, I change from positive to negative. So I know that I have a max at 3. Does that make sense, guys? Okay. You okay, Kyle? You okay? Yeah. Okay, I'm making sure, Miss. All right. Check it out, Miss Houston. Ready? Yeah. Remember that 5,000 that you were talking about? Yes. So I'm going to say amount equals 5,000 plus, that's my initial amount, at what time? Was it at time 0? Okay, plus, I'm going to go integral. From 0, I'm doing this one first. Actually, I'm doing this one right here first. From 0 to 3. Is that in pieces? No, it isn't. So I'm going to do it perfect. Ready? I'm going to go, hey, relax. My net rate is F of T minus G of T dt. This will tell me how much I have right at 3. Does that make sense? And don't worry, Chubb, but it breaks up in pieces. I only have to worry about this part that I'm circling in black. And that part that I'm circling in black, G of T is always just what? Yeah, what was that? What was that number? Was it 250? It's always just 250. See? Does that make sense to you guys?
So what we're trying to find the average.
No. I'm not finding average. I'm just finding the amount. So 0, 5,000. I'm just finding the amount. So take your calculator. Did I put F of T in here, guys? Is that it? Okay. I can just type it, the other one. So I'm going to go math, number 9, from 0 to what? 3 of what? Alpha trace y1 minus, what was it, 250? That's a rate, x. Are we okay, guys? Enter. So there it is, 126.591 gallons. Wait, oh, I got to add 5,000. Plus 5,000. What? That's the rate, miss. That's what's coming out.
The piecewise function. Oh, 254.
Yeah, f of t minus g of t. That's the rate between 0 and 3.
Yeah.
So hook me up with the number again. I already forgot it. 5,026. Point what? 590. Did they want to the nearest gallons? Okay, so don't worry. We'll fix it right now. I don't care about the 5.076 because I know between 3 and 5.076 GT is bigger than FT, so I know it's going down. Does that make sense? So I know that's going to be a number smaller than 5,126. So I don't care about that one. Now I care about 7. So let's see how we're going to do that one. Actually, we're going to have to take that number into account, right? Because this is how much gallons I have right now at the moment at t equals 3. So I'm going to do this. Amount, relax, you're gather fine. And I'm going to give the amount. Here's what I'm doing. Let me write it down. Let me talk about logic first, and then you guys tell me if it makes sense. Amount at 7 equals the amount at 3 plus integral from 3 to 7 of f of t minus g of t. So let me see if that makes sense to you guys. Okay. Can you guys see? Tell me if this makes sense. The amount of gallons I have at 7 is the amount of gallons I had at 3 plus how much I have changed from 3 all the way to 7. Does that make sense to you guys? Now, why did I break it up like that? Because of this. Because of the piecewise function. This is making it harder. Do you guys see that? Because I don't have a clear way of how, let's see. So I have to start, I'm going to stop right at 3. And whatever amount of gallons I have now, because my GOT is way over here, it's a jump discontinuity. Now I have to reset from that moment at t equals 3. Yeah, that one was hard. I bet you the amount of points in that one is low. What's up?
So then, say it wasn't piecewise function and it's like one function, we would just do 0 to 7 of
Yes, if it was. I haven't. Oh, I just did right now, but I haven't looked at the real amount how it looks. So here it is, guys. I'm gonna go math. I'm gonna just click that one right there, enter, and I'm gonna go plus math 9 from 3 to what? 7, and I'm gonna type in alpha trace y1 minus not 250, 2,000. Put x, and let's see what we get. 4,513. 4,513.806. Well, on mine, because I haven't rounded it yet. Okay, which one's the biggest? 3. So, and what did they want? The time? At what time is the amount of water in the tank greatest? The nearest gallons compute. Oh, they want both. So circle this one and then go at t equals 3. There is 5,127 gallons. Ooh, that was hard. That was hard, guys. That was hard because it was different. But good thing we're getting that experience now. So how do we do? Okay, full disclosure. I saw it when I was cutting and pasting it, but I didn't concentrate on it. So it might look different. It might not. Let's see. Letter A is going to look the same all the time, forever and ever for everyone. We didn't put the approximate symbol, but that's fine. Did we get the 2 points there? Yeah. Letter B. The amount of water in the tank is decreasing on the interval, blah and blah. Okay, look, they put the equal signs. We're fine. We got the points. It doesn't have to look exactly like that. Since f of t less than gt, between that and that. Notice they didn't put the equal signs right at 3. But yeah, we got the full points, guys. Interval and reason. Oh, look what they did. Man, I like ours better. That's fine. Did we get 5,126? And yeah, we got it, guys. 4,513. The amount of water, don't round it to the very end. The amount of water in the tank is greatest at t equals 3 hours. At that time, the amount of water in the tank rounded to the nearest gallons is 5,127. I like ours better. Look at all the points. Crazy, right? Okay, how do we feel?
That was a good one.
Yeah, it's a way to go, way to start the class. We started with the hardest one probably. I don't know. That was pretty tough.
I feel like those just make more sense than the ones we've done previously.
This one I think we should have done first because I think this one looks easier. Okay, so we're doing good. We're winning. Are you guys happy? Look, this is a tight question, guys. With sand, who creates these models? You think they just make them up? No, I think these models, like if you open a physics book, it has a whole bunch of formulas. They're models. Well, maybe someone made them up. I don't know. But let's see. The tide removes sand from sand. Who writes these? They call this Sandy Point Beach. The tide removes sand from Sandy Point Beach.
Stop laughing.
Sorry, miss. Sorry for having joy.
Why is it funny? Sorry.
Because it's called Sandy and there's sand. Okay. The tide removes sand from Sandy Point Beach at a rate modeled by the function R. So here it is. They're kind of, this is out. They're using R as remove. A pumping station adds sand to the beach at a rate modeled by the function S given by, so this is in. Out and in. Are we still okay? Both RT and ST have units of cubic yards per hour, and T is measured in hours between 0 and 6. At time T equals 0, the beach contains 2,500 cubic yards of sand. Okay, we got it. Are we okay so far? Do we understand what we're doing? How much, bless you squared. Stop sneezing. How much sand will the tide remove from the beach during the 6-hour period? Indicate units of measure. What am I doing? Integral of what? From 0 to 6 of? There it is. Put this in y1. Put this in y2. Do not use calculator language. This is just for notes. So put that in y1, put that in y2. So y1, because we're probably going to need both. 2 plus, hook me up with it. 2 plus 5, sine of what? 4 pi x over 25. Alpha y equals, enter 4 pi x over 25. Okay, what's y2? Okay, alpha y equals 15x over, like that. Okay. Let's see what we have. Equals, this is called the setup. It's all calculator. I'm just going to go, let me clear this. Math 9, from what to what? 0 to 6, and they want rate out. I believe I have that in y1. And here we go. Did you guys get 31.8159? 31.8159. And I need units. Cubic yards. It's cubic yards times time. This was a rate, cubic yards per hour times hour, so it's cubic yards. All right, are we good? All right, letter B. Write an expression. Oh, they're telling you what to call it. Y of t, the total number of cubic yards of sand on the beach at time t. I love this question, guys. It's always going to look the same. With Kyle, you're going to give me the equation.
Wait, can I do it?
Okay, you can do it. And then if you get stuck, Kyle's your lifeline.
Okay, it's going to be 2,500.
Is that how much I have initially?
Yes. Plus.
Integral.
Of 0 to t.
0 to t.
And then parentheses.
How much do I have going in?
It's going to be s of t. Wait, what
No.
did we put s of x?
No. How much do I have? Oh, yeah, S of t. You said S of t. Yeah. Sorry, miss.
S of t minus r of t.
There you go. You got it. Oh, yeah. It doesn't matter. Okay. Yeah, I see what you were talking about now. This is called a dummy variable. And if it bothers you, in physics, they do this all the time. They don't care about it. If it bothers you, just change the letter. What do you guys want in there instead of a t and x? Keep it? Okay, keep it. That's fine. You're fine. Yes.
What happens if you don't put t, we put 6?
Yes, because if you put 6, it's like, where? Like up here? Or yes, if you put 6, you found the total amount of yards at 6. So you got to put it up there, t. And I'm going to squint my eyes, and it's going to look like an x. You don't have to change it, guys. They would probably give you full credit. They will give you full credit. But you usually want to have a different letter. In physics, they don't care. Good job. No, that has to be a t because that has to match this. No, it's a dummy variable. You can have them all STs. Because you're analyzing upper minus lower. If you put like a 5 in there, you're not. I mean, I know what you're saying because you have a t there and a t there, and like, doesn't that mean 5 there? You're analyzing the integral first. That's why you want to change the letters. But in physics, the professors, you can open up a textbook and they do it all the time. They have all the same letters for everything. This is the better route. Are we okay, guys? All right. Letter C. Find the rate at which the total amount of sand on the beach is changing at t equals 4. Okay, they just want to know. Oh, they want to know the rate. Find the rate. So they want to know the rates at which the total amount of sand is changing. Am I taking the derivative, or is this already a rate? That's already a rate. Does that make sense? So we're going to go in minus out. In is S of 4 minus, what's the out one? R of 4 equals, and then make sure we put units. So I already have that. I have that one in Y2. Alpha trace Y2. Man, we did that one fast. We didn't even hesitate. Minus alpha trace Y1. And there it is, negative 1.90875. Negative 1.9. You guys got it? 0875. 0875. And I need units. Yards per hour. Is that all they wanted? Okay, I think that's all they want. Cubic yards per hour. Cubic yards per hour. Okay, I think we're good. Letter D, between 0 and 6. At what time is the amount of sand on the beach a minimum? What is the minimum value? Justify your answer. Okay. I'm gonna write. This is gonna be the same, just as always, guys. This is my justification. I need the amount, and they call that y, right? Y of t. All right. Y of t. Let me go ahead and write my expression again. Y of t is equal to what De Leon said: 2,000 integral 0 to t of s of t or s of x. Was it? I already forgot. What was it? 2,500. Yeah. 2,500. Sorry, guys. My memory is not good right now because I didn't get much sleep, but I'm sure you guys are the same way. S of t minus r of x. We still okay? All right. I am gonna look for where s of x or s of t, whatever you want to write, minus r of x equals 0. And let me explain. You ready, Kyle? This is just like the last question. I'm sorry. I'm not picking on you. I promise. Is s of x minus r of x is positive, that means I have more sand being added to the beach. Yeah. So the amount of sand is increasing. Yes or no? Yeah. Is s of x minus r of x is negative, that means more sand is being removed. Yeah, the amount of sand is decreasing. More sand is being removed from the beach. Does that make sense? So I am looking for, do they want a min or a max? I am looking for where s of x minus r of x changes from negative to positive. And I don't care about the positive to negative. Does that make sense? So I put this here so the reader can know that I'm looking for my critical numbers. And if it is a positive to a negative, I'm just going to put it in here, but I'm going to put NA. That's a max. So say it again. Yes. Yes. I know that if s of x minus r of x, I know if you split your right, that looks like it. If this is negative, that means that the amount of sand is decreasing. And if this is positive, I know that the amount of sand is increasing. So where do I have a minimum? When the s of x minus r of x goes from negative to positive. Does that make sense? All right. At 0, I have how much? 2,500. So that one we already know. So I'm going to type this in. Do I already have it in here? Yes, I do. So here we go. I'm going to turn off Y1. I'm going to turn off Y2. I guess I could just start at Y2, but here it is. The Y2 is the in, right? So I'm going to go to Y3. I'm going to go Y2 minus Y1. Does everyone know what I'm doing right now? Okay, I'm going to click on window, and I'm going to go from what to what? From 0 to 6. 0 to 6. Yeah, negative to positive, -5 to 5, or negative, because you just care about where you cross the x-axis. And then push graph, and there it is. Oh, look at that. We already found it. There's only one critical number, and that's the one that's going to happen. Give me that one. How do I tell the calculator to give it to me? Second trace or calculate, and then which one?
0.
No, not 5, but the 0. Number 2. And then it says left bound. Yeah, that's fine. And then when it says right bound, go to the right of that 0. To the right. That's how I know I need to get sleep. And there it is, 5.1178. So on this, I don't have to show anything. I'm just going to show that. I'm going to go t equals 5 point, and I already forgot it. Yeah, as many digits as you can. 1178, what? 653. And I'm going to store this. Did I already use the letter A anywhere? Okay, I'm going to store it to letter A as long as you're not using it. So I put a little arrow. I put an A. So then I can just go A right here. And here it is. I'm just going to find out what that is. So I'm going to go, let me see, second quit, X store alpha A.
Why are you using that as value for T?
Say it again.
Why are you using A as a value for T?
Well, I could use any letter, but I just go down the alphabet.
No, not like specifically A, but like that number.
Oh, because that's my critical number. That's where I have my absolute minimum. Because my derivative changes from negative to positive. Or your S of A minus R of A goes from...
So because it's a rate, that's all we know?
This is a rate, yeah. So that's a minimum, right? Yes. So here we go. I'm going to go 2,500 plus math 9 from 0 to A. Do I already have the rate in Y? I do, in Y3, right? Alpha trace Y3 and X. Bam. 2492.369. 2492.369. And then don't forget, you got to check your 6 to make a global argument. And then I'm just going to scroll up and put, obviously at 6 you're going to get a little bit bigger, right? 6. And 2493. Yeah, it should be a little bit bigger, and it is. 2493.27667. 2493.27667. All right. What is the minimum value? What is the time t for the amount? Okay. The amount, the minimum value, do they care about rounding? Okay, so then you want 3 digits after the decimal. The min value of sand is 2,492.369 cubic yards at T equals 5.1178653. Full credit. How do we feel? Did the what? 2492? Oh, this is a 6? I typed it in here like that. 0 to 6. Let's look at the rubric, guys. See how we did? Did we get letter A? Yeah. Did we get letter B? Yeah. You would have been fine if you would have had a T in here as well, but you don't want to, you prefer to do it, with different letter. You can put any letter. It doesn't have to be an X. It could be any letter. Letter C, I didn't even call that Y prime. I don't remember. Yeah, I didn't even call it Y prime. We just did this. We just did S of T minus R of T. No, you did not. But it would be nice if you recognize it. Yeah, it is Y prime. Check it out. Fundamental theorem of calculus. If you take the derivative of Y prime, the 2,500 goes away and you get S of X minus R of X. Or S of T minus R of T. You don't have to call it Y prime. You're good. Did we get negative 1.908? Okay, got it. Perfect. Ours is going to look like that. They called it little a, lame, whatever. The amount of sand is minimum when T equals 5.117 or 5.118. The minimum value is that. How do you guys feel? All right. Is this making sense to you guys? All right, guys. This is the last question we have. Work on it as a group, and we'll call it a day. Yes.